Hello, everyone. Thank you for your time today. My name is Rishabh Ray Chaudhary. I'm a senior product manager with Amazon SageMaker. I'm here joined by Ram Vegiraju, who's ML solution architect with SageMaker as well. We are here to talk to you about, sorry about that. We are here to talk to you about Amazon SageMaker Serverless Inference, which is a new feature that we launched this week. And we're going to talk about what are the key benefits, what is the value proposition that we are offering, how to deploy on serverless inference. So let's get started. So the agenda for today, we'll start off with the why. Why is there a need for serverless inference? Secondly, we'll talk about the what. What is serverless inference? What are the key benefits? What is the value proposition that you get? Thirdly, we'll talk about the how. How can you deploy on serverless inference? What are the steps that you need to take? And then we'll wrap it up with a quick demo and Q&A. Before we dive deep into serverless inference, we first wanted to give you a quick preview of the different inference options that you have with SageMaker today. Today, we already offered 3 inference options. The first one is real-time inference, which is specifically useful for low latency, high throughput workloads. We support a bunch of ML-specific features such as multi-model endpoints, A/B testing, model monitoring, model registry, and a lot of customers are already using it. The second one is batch transform, which is specifically useful in cases where you have the data available upfront, and if you want to process inference requests and processing jobs offline, and then save the data in an S3 bucket. The third one is asynchronous inference. This is something that we recently launched in August this year. It's near real time, but the key benefit is that we support larger payload size, and we also support longer timeouts, up to 15 minutes. So it's particularly useful for computer vision types of workloads. And we're already seeing a lot of customers adopting this new feature, so that's really great to see. So even with these inference options, when we talk to customers, we today see 2 main challenges, and some of these challenges might resonate with you as well. So first one is when your workload is intermittent. So let's say if you see traffic from Monday to Friday, and if you don't see traffic on weekends, and similarly, if you see traffic, let's say during the day, but after midnight, you don't see traffic, today, customers still have to provision capacity or provision instances in order to maintain the performance goals. But the problem with that is basically, the utilization rate is going to be low, but the cost is going to be high. And customers want to cut down on the cost when the traffic is low or intermittent. So that is problem number 1. The second problem that we hear from customers is when we speak to ML practitioners and data scientists, they typically say that they want to focus their time and effort in optimizing the ML code rather than focusing on managing the infrastructure. So today, to provision instances, they'll have to first identify what is the right instance. They need to do load testing. They need to identify how many instances are required. They'll need to do management of all the auto-scaling policies. And that takes up a lot of time, and that increases your total cost of ownership. So these are the 2 main challenges that customers have brought up to us, and that's the reason we are really excited to introduce to you Amazon SageMaker Serverless Inference. This is the first purpose-built serverless ML inference in cloud. It's a fully managed service, so you get the benefit of a managed service like other inference options that you have with SageMaker. Third, and this is also very important, you only pay for what you use. So you don't pay for any of the idle time. So that significantly reduces your cost structure, and you can save money, which you can invest in other projects. Now let's talk through some of the key benefits that you get out of the box with this new feature. First, as I said, it's a fully managed offering. So SageMaker is going to manage the security, monitoring, logging of the underlying infrastructure. You get the same built-in availability and fault tolerance that you get with other SageMaker inference options today. Secondly, it's serverless, right? So as the name suggests, you don't have to manage any servers. You don't have to provision any instances. The only thing that we'll require from you is a memory configuration. So once you provide us the memory configuration, we'll automatically assign compute resources in the backend proportional to the memory that you provide us. That's a significant advantage because that helps reduce the amount of time that you are investing in managing infrastructure. Lastly, we'll automatically scale in, scale out, and scale down to 0. So you don't have to manage any of the scaling policies. You don't have to turn down instances when there is no traffic, right? So again, you're saving a lot of time and effort that you're today investing probably in management of infrastructure. The second benefit is you pay only for what you use. The primary dimension for serverless inference is going to be inference duration. By inference duration, what we mean is the amount of time it is going to take to compute, the amount of compute time it's going to take to process the inference request. And that will depend on the memory configuration that you provide. So for a 1 GB memory, you'll get a certain particular rate, but if you choose a 6 GB of memory, in that case, it'll be 6 times that rate. So it'll grow proportional to the amount of memory that you allocate to the endpoint. The second benefit, as I said, there is no charge for any idle time. Thirdly, you are going to be billed at a millisecond granularity. So that means you are going to further optimize your cost because you're only going to get charged on a millisecond level. And lastly, we're also offering a free tier. So you get 150,000 seconds of free tier per month for the first 2 months of inference duration. That's a great opportunity for you to test out the feature, see how it works, then deploy a model. And the third benefit, it's purpose-built for ML. So given it's a SageMaker-specific feature, you get the benefit of the entire SageMaker ecosystem. We will support first-party algorithms that SageMaker provides. You can deploy optimized ML frameworks that SageMaker provides. You can bring in your own code, your own custom container, and deploy on serverless endpoints. And the other really cool benefit that you get with this feature is that you can use the same container, and you can deploy it on real-time endpoints, which is instance-based, and you can use the same container and then deploy on serverless endpoints. You don't have to make any changes to it to make it compatible with the underlying infrastructure. That's a great benefit that you get because it gives you a lot of flexibility to move between different inference options. So let's say today your traffic is intermittent. You deploy on serverless endpoints, but tomorrow it becomes more stable, and if you want to move to an instance-based endpoint, you just need to update the endpoint. It takes a few minutes, and then your endpoint will be set up. Now let's talk through a customer use case. Let's say Sarah works as a DevOps engineer for an online food delivery app. She uses ML to provide personalized restaurant recommendation to her customers, right? So if someone goes and searches for pizza delivery, her ML algorithm is going to show the list of the top restaurants in that particular zip code. Now, one of the challenges that she faces today is the traffic pattern is highly unpredictable. During lunchtime and during dinner time, there is peaks, but then for the remaining part of the day, there is not enough traffic. After midnight, there is probably idle time. Plus, the fluctuation is very difficult to predict. During holidays, it peaks even further. And it's difficult to know how much it's going to predict, how much it's going to peak. So now, as a result, there are two challenges that she's facing. First, managing auto-scaling policies is going to be a challenge because predicting the demand is a challenge itself. And secondly, the inference cost goes up. Because she has certain performance goals, she ends up over-provisioning instances, right, in order to make sure that all the inference requests get a result back. But that increases the inference cost further. So now Sarah decides to attend reInvent 2021, and she attends this session. So she learns that SageMaker is launching this new feature. So she then decides to test it out using our free tier. So what she learns is two things. Firstly, given it is serverless, so we'll automatically scale in, scale out. There is no management of scaling policies, right? So that's a significant benefit that she gets. The other benefit that she gets is that she now doesn't need to over-provision capacity, right? Because we will automatically scale based on the demand pattern, and she doesn't need to set any of the scaling policies. So there are two things that come out from this use case. The first thing is that it's a fully managed service. So she saves her time. She doesn't have to identify what is the right instance type, identify how many instances to load up, identify or manage auto-scaling policies. And now she can optimize her ML code rather than focusing on the infrastructure. The second benefit is that her inference cost goes down. And for her company, it goes down because now they're only paying for what they're using. They're not paying for any of the idle time. So as a result, if you see, the total cost of ownership for her company goes down because they save time that people are currently investing. They also save cost of inference. That's a significant benefit that they get out of serverless inference. But at the same time, I also want to call out that serverless inference is specifically ideal for workloads which have intermittent or fluctuating demand. It's not ideal for all kind of workloads. And that is why we offer you different inference options. So if you know that you're going to get 100 requests per minute for the entire day, then you should go with real-time endpoints because it's predictable demand, and you can use instance-based. You're not charged when there is no traffic. Sorry, you are going to be charged when there is no traffic, but in that case, you know how much traffic it is. So that's the one thing. Now let's talk through how to deploy on SageMaker serverless inference. It's a simple one-click deployment, and we've put in significant effort to make sure that the experience that you have today with other inference options, you have the same experience even with serverless inference. And again, the purpose is to give you flexibility and portability between different inference options within SageMaker. So you need to provide three things in order to create a serverless endpoint. The first is an ECR image of your inference code. Secondly, you need to provide the S3 location of your model artifacts. And third, you need to choose a memory configuration based on your model needs. Now, as I said earlier, you can choose between 1 to 6 GB at 1 GB increments. And once you provide these three things, we'll automatically spin up and manage compute resources in the backend. We'll automatically scale based on the demand. We'll also manage the logging and monitoring into CloudWatch. So once the endpoint is set up, you can trigger inference requests from other AWS services or from your client applications and get inference results back. So that's the overall flow. And I'll quickly wanted to run you through the console experience as well. So again, in the console, the experience is exactly same with what you currently have with other inference options. You'll have either three steps that you need to follow. First, you have to create a model where you'll have to provide the ECR image location and the S3 location of model artifacts. Second, and this is the critical step. So this is the step where it's going to be slightly different than what you've currently probably used for SageMaker inference. So if you look at the screenshot on the left, there are two options that you'll see. One is provisioned, the other one is serverless. So if you click serverless and then add your model here, you'll automatically assign 1 GB of memory to your endpoint. You can update that or upgrade that endpoint, upgrade that memory configuration, and that is shown in the screenshot on the right, by just editing it and updating it to up to 6 GB. And once the endpoint config is created, you have to use that endpoint config, and then it's just a one-click step to create that endpoint. It'll take a few minutes to set it up, and once it's in service, you can trigger inference request to that endpoint. So it's a pretty straightforward, simple process through console. And with that, I'll hand it over to Ram to take you through the demo.
Cool. Just give me 1 second to get started, and then I'll get this up and ready. Just for some reference before I get into all of this, have any of you have, just a raise of hands, if any of you have deployed a SageMaker endpoint before or worked with SageMaker? I just got a raise of hands there. Cool. Sounds good. So let me grab the screen share real quick. Awesome. So for today's demo, we'll go through a lot of what Rishabh just talked about. There's two different examples that we're going to be discussing. The first one that you're seeing right here is SageMaker XGBoost, which is one of Amazon's built-in algorithms that they offer. And we support the container there, and we're just going to be retrieving that and solving a simple regression problem with the abalone data set. And the second one is a bit more complex just in nature, which is bring your own container. So if you have a custom framework that SageMaker doesn't support or provide, we'll dive into how you could bring your own container and create a serverless endpoint from the steps that we detailed. So the first one we'll go over is the XGBoost example right here. And all of this right here that you're seeing is setup that is common for even a real-time inference endpoint, anything of that sort. You're going to be importing your Boto3 client, which is your Python SDK essentially. And we have SDKs for Java and different languages as well. But this SDK can pretty much be used to orchestrate and do a lot of what Rishabh showed in those console screenshots. So those steps that you see about model creation, endpoint configuration creation, endpoint creation, and then invoking the endpoint, it's all done through this Boto3 client right here. And if you notice, we're creating two clients. This first client will be used pretty much for creating the model, the endpoint config and endpoint, and the second one will be used to invoke your serverless endpoint itself. So once we get all of that set up, we're retrieving the data, and this part's not really that relevant to inference itself, but we're going to be training our model using this XGBoost algorithm. And the key part that you want to focus on right here is this image URI portion. Using the Python SDK, we're going to be retrieving that XGBoost algorithm, and as we detailed for model creation, you have two steps. You need to specify the image, whether we support it or whether you brought it on your own. So this is the first step, and then after this, you provide that image and you create this training estimator, and you can train it on whatever data you're working with. The second part is we need to grab the model artifacts. So model artifacts are the model data. After XGBoost model has been trained, we need to retrieve these artifacts from S3. And S3 is just where everything is pretty much dumped in for a SageMaker, from training to model artifacts to output. It kind of goes hand in hand with it. So once we have those two parameters, right, model artifacts and the image URI, we can go into our first step. And this first step is actually common for both real-time and serverless endpoints. So the three steps, as Rishabh mentioned, it's kind of going to be like the recipe here for both real-time and serverless. Model creation, which will require your image URI or the image that you're providing along with your model data. And then after model creation, you'll have endpoint configuration creation, which is kind of telling your endpoint, I'm either serverless or I'm real-time or I'm asynchronous. That's where you specify what type of endpoint you're dealing with. And then you finally create your endpoint, which is common for both serverless and real-time. So if we go into model creation right here, you'll notice we're using that client to create the model. And within that client, we're specifying a parameter known as containers. And within containers, there's two features that are necessary. That image, which is the image URI that we retrieved earlier, that XGBoost image that we were working with. And then the second part is after that training job, we have those model artifacts, right, from that trained model. We're providing that, and we're going to be using that to create a model. And you'll be able to see this model in the console. If you go to the console and go to inference, let me load that up, and while that's loading, I'll go right here. So if we go back to the SageMaker console right here, you should be able to go to inference. And underneath here, you'll see those three steps. So models, endpoint configuration, and the different type of stuff you might be working with. And then if you go back here, this is where you can specify, I'm dealing with a serverless endpoint. It's not a real-time endpoint anymore. Because when we're doing this create endpoint config call, we're going to be specifying an extra parameter in serverless config. And there's two knobs you can adjust there, right? Memory size, and generally for memory, we suggest it should at least be as large as whatever model you're working with. So if you have a 3 GB model, make sure your memory is at the minimum at least 3 GB. And then max concurrency, which is currently 50 for the limit. And those are the two things that you can adjust. And this can also be replicated in the console, right? So if I go to endpoint config right here, if you don't want to use the SDK, you can click create endpoint configuration, and then you can name it whatever, specify that it's serverless. You could add a model. So for example, one of these existing models, you can save it there. You can edit your memory size in max concurrency based off whatever parameter you want to work with. And we've already created that just through the SDK here. And that'll bring us to our final step, right? Which is the actual endpoint creation. And we have this pre-created ahead of time because this step generally takes about 3 to 4 minutes just to kind of load and create, and you can monitor and track it with this small script right here. And then after that's done, you could see the invocation results, right? So if I invoke this endpoint right now, you'll notice it's going through and we're getting a response. This payload is just a sample payload, one row from the Avalon data set. So that's in general what the end-to-end flow looks like, and that's with our built-in algorithm. So it was a very simple process because we're able to retrieve it directly using the SDK because it's already supported. But normally, we go one step above, right? A lot of you are going to be dealing with custom frameworks in machine learning, sometimes not even using TensorFlow, PyTorch, scikit-learn, or like the normal deep learning models. So let's say we're dealing with a framework, in this case, this example, LightGBM, and it's under this BYOC folder right here. This LightGBM, it's a framework we don't support. And this is an example of how to bring a custom framework. So this could be SpaCy, NLTK, any type of custom machine learning library that you're dealing with. So before I go into BYOC, which is bring your own container, just kind of a short acronym for that, we can talk about what this setup looks like in general. Say you have a custom framework that you want to bring to SageMaker. How do I do that exactly? So what we do, everything in SageMaker is containerized. And SageMaker is directly also integrated with Elastic Container Registry, where you can build and push Docker images. So what we ask is when you have a custom framework, in a Docker file, can you provide the dependencies needed for that framework? What do you need to install LightGBM and work with that? And then we give the setup. Underneath the hood, our inference is being conducted in a Flask web server. So the main parts that need to change are this predictor.py and this Docker file. You can have your inference code in the predictor.py file, where you can load up your model and do inference. Or if you have training, you can do that in this train portion right here. And then you can build that Docker file, right, which contains whatever dependencies you're dealing with. So if we return to the example, you'll notice I have a container directory right here. And here I have a Docker file that's installing LightGBM. And here I actually have a Flask app that's loading up my model that I'm dealing with and returning inference. So that's how you could bring kind of a custom framework to mind. And this was a simpler example, but you can elevate that and adjust that based off the one you're dealing with. So once again, the steps, now that you've built your container, the steps are very, very simple after that. It's really similar to what we were dealing with before. If we go back here, the first thing you have to do is you have to build and push that Docker image. As I said, SageMaker kind of works directly with Elastic Container Registry. So you're going to build and push it. This cell right here is replicable. You could use this exactly as it is for your Docker file or Docker image that you have, and you can locally test it first. And once you've done that, you can push it to ECR. So you'll notice this is a registry that's created, and now we have an image URI. We have an image URI that we can plant in. So if we go back, once again, the same recipe, right? The 3 steps: model creation, endpoint configuration creation, endpoint creation. For model creation, if we remembered, there are 2 things we needed: image URI and model data. So now the difference is we created our own image URI because we pushed our own image. And we're going to be referencing that in this container portion right here. And we're going to be feeding in our model data, and we'll feed in that container with those 2 parameters. So right now, if you're on real-time inference right now, for example, and you already have a custom image, all you need to do is grab that image URI and plug it in here. That's what's great about serverless right here, because if you already have a real-time existing endpoint with whatever custom framework, all you have to do is grab that image URI and bring it over to this step. And then a lot of the same steps that you'll see again: endpoint config creation, you reference that model, you create it based off whatever's happening in that model, you're based off your image. Those are the only 2 things that change: the image URI and model data based off your custom framework. And then you can go into endpoint creation. Once again, it might take us a few minutes to get that up and running fully, but then if we go to our invocation for this, we can run that, and that might take a few seconds, but once again, you can see it right here in endpoints. You should be able to see both of these endpoints have been created, and if we invoke this, we'll be able to see our results right there. And with that, at least right now, I think those are the 2 different ways you could look at it. If you have a custom framework, it's a certain way that you could port over whatever framework you're dealing with. And overall, we encourage you to at least, like, if you're dealing with TensorFlow, PyTorch, or scikit-learn or Hugging Face, which we support, it's normally easier, as you can see with that XGBoost algorithm, that you can grab and pull that image and build off of it. So with that, I think I'll clean up the demo for now, and I'll hand it off to Rishabh for Q&A.
Thanks, Ram. So I think there are a few other things that we wanted to share with you before we start Q&A. The first thing is that it's in preview. So it's in 6 regions currently available for you to start using, start testing. We also have the links to the documentation, the FAQs, and the example notebook. I think the example notebook is a great place for you to start. That's basically what Ram showed today. You can use that, test it out, and then start deploying your own models. So yeah, I think that's pretty much covers everything that we had. And we wanted to open it up for Q&A. We have about 30 minutes, so we have a lot of time for to answer your questions, comments, anything. Sure. So it won't, like when you say it could run out of memory as in, right. It is not going to, so basically when you're creating the endpoint and when you're testing it, at that point of time you'll specify the memory which is proportional to your model size. So if your model size is 1 GB, you'll choose something like 2 GB memory, right? So that way it basically downloads them. So when there is inference request, we'll download that and then process the inference request. We're also offering temp storage or disk storage for 5 GB. So you can at max have up to 5 GBs of model that you can use for inference, but nothing more than 5 GB.
First.
Yeah, sorry. That's a good question. So it will depend on your model size. So if it is a larger model, it will take us more time to download the model. But there will be cold start, particularly if there is no request for a certain period of time, and then there is a new request, we'll have to download that model, warm up that underlying compute resource. So that is basically cold start, and that will happen, and that will depend on the model size. It can vary from seconds to maybe a minute or two. So that'll, and you'll have to test it out with different model sizes and see, different memory sizes and see which one works best for you. No, so we are not using ECS Fargate. Yeah, but there are a bunch of other AWS services that we are using. Yeah. So it's coming soon. It's going to be next year. For now, we are, as I said, in preview, but we'll soon, like by early to mid next year, you should have it MGA. Yeah. Yeah. So that's right. So so currently we are not having that option. So if you have like a requirement to keep the instance warm or the compute warm, in that case, we'll still recommend that you use real-time endpoints, because there you can assign a small, medium instance, and then it's still cost effective, but you still have an instance which can respond back to request. It is similar to Lambda in a way, because we are integrating with Lambda and a bunch of other services to bring this to you. So yeah, so it is going to be similar to Lambda, where in terms of cold start and in terms of how we load it up in the model. Yeah. So we are not currently supporting provision concurrency. As I said, like we have real-time endpoints already with SageMaker. So if you know that you want to keep your endpoints warm for certain duration, you can use real-time. At the same time, as I said earlier, you can update your endpoint from serverless to real-time during preview. In the future, we'll also support the reverse, where you can move from real-time endpoints to serverless. So that will give you the flexibility. Like if you see that after midnight there is no traffic, so you want to move to serverless, so you can update the endpoint and then During the day when there is traffic, you can move back to real time. That is one possibility. Yeah. Yeah. Sorry. So we can't guarantee you a time, like a time. Right. You can certainly do that, but again, like we don't recommend you doing that because then you're basically creating an instance, right? Means it's similar to having an instance. You have something up and warm all the time. So that is like a real-time endpoint. So, right, right, right. So means I can't comment on the exact time frame. Yeah, let's say whatever time. So let's say if you ping every second, yes, it will be warm. Correct. Yeah. So currently we don't have model monitoring because it's in preview. Model monitoring is not integrated, but it's going to come soon. We are working really hard to add the features that you currently have on real-time endpoints. So we want to have similar features on serverless as well. Yes. Yeah, I mean, we can't comment on that. And it's not just Lambda, as I said, behind the scenes. Lambda is one of the services that we integrate with, but then there are other services as well. These are no, we are not supporting GPU at this point of time. Yeah. Yeah, sir. So your question is, are we supporting CloudForm? Yeah. So, yeah, we basically the same way that you currently deploy through for real time, you can do that for serverless as well. Is there? I don't. Sorry. Yeah.
Wait, sorry, could you just repeat it again once? Mm-hmm. 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 It's the same thing. So multi-model server is still happening in the background and all of that, but underneath the hood, inference is still served on, since it's the HTTP endpoint, there's two routes, dash ping and dash invocations. That's the part I showed in the predictor.py. So even with multi-model server, it integrates with those two routes. So that dash ping is the health check, if you want to check if your model is loaded properly or if your container is healthy, and invocations is where your inference logic can go. So it's still with MMS, and it's still the same infrastructure underneath the hood. It's just that that's the flask gap that's actually being implemented when you're dealing with the custom thing. Yeah, the environment variables and stuff should be the same in terms of when you bring it over. The only thing that's going to change is when you have that image URI, you just want to, once again, you can replicate it exactly as you have your BYOC setup. Mm-hmm. Yeah, that's totally different. So creating the endpoint, that's just a platform type thing. And there's actually been improvements there. So before it was 6 to 7 minutes. Now it's come down to like about 3 or 4. And I think that's constantly being worked on. That's not related at all to like a cold start. Yeah, two totally different things. Yeah. So for batch transform, I mean, that's if you don't care about having a persistent endpoint, right? So if you need an endpoint that's being invoked, like say in a larger application or something, then you want to look into real-time or serverless. Batch transform is more for offline predictions. So if you have like a chunk of video data or chunk of image data for your computer vision workloads, and you just want the output results outputted, then you use batch transform. There's no endpoint related in that. That's just offline predictions then. And serverless, once again, the difference between that and real-time is if you have you need an endpoint, but if you're okay with like, if you have intermittent workloads and stuff, and you're okay with that bit of a cold start and everything, but also you want the auto scaling and everything managed, then you should pick serverless. With real time, if you're really specific on traffic, and this is when it gets a bit more advanced, where serverless makes it easy. With real time, you can configure an auto scaling policy. If you think there will be traffic higher on like a Monday or a Tuesday, you can scale out the number of instances for that.
Max concurrency is not going to directly impact cost as such. It's basically how many concurrent requests that particular endpoint is going to respond back to. More from a performance, not even like, yeah, I mean, basically scaling and performance is probably going to be determined by max concurrency. And you can, so we have a limit on max concurrency per endpoint and also across all endpoints for a region. So per endpoint, it's going to be 50, and across all endpoints for that region is 200 during preview. So you can choose to deploy like 4 endpoints with up to 50 concurrency. Correct, for that region specifically. Correct. Yeah. Other questions? Let's see.
I can't see it.
If there's no other question, I think we can call it a wrap. Thank you so much, everyone, for your time today.
Thank you, everyone.
Really excited and look forward to working with you all. Thank you.